Hello everyone. So we're going to continue with solving triangles using any type of kind of method or that we know from previous grades, and and that includes Pythagorean using Pythagorean Theorem. That includes the very basic Euclidean geometry, where the sum of the interior angles of a triangle equal to 180 degrees, which is right there. And also we can use the trigonometry, the sine and cosine and tangent ratio. Okay, all of those we can use, and we can use that to solve a triangle. Now when we say solve a triangle or solve the triangle, we mean that everything about that triangle needs to be known: angles, sides, length, anything. So look at this example right here. So in this case, there's one side missing right here, and also the angles right here and right there missing. Okay, so that means we're solving everything about this triangle. So let's look at example 1, or A. Find all the missing angles and or sides of any given triangle. Answers rounded to 1 decimal place. Okay, and we can use any method. Here are the three. You can sometimes use all of them, one of them, or two of them. It doesn't matter. All right, so we can use all of that. So let's start with the side x. How can we solve for that? Well, we can use Pythagorean. So what is that? Well, that is x squared is equal to hypotenuse is squared, subtract away the other side squared. Okay, simple as that. So x squared is equal to, and when you do this, you can simply look at the math on that and then do the math, and simple as that. Okay, so 18 squared 324, 7 squared, just do the power of 2 in each, then subtract, you get 275, take the square root of both sides, x equals to 16.58, and because the question says 1 decimal place, we're going to go 16.6 approximation, and that's the centimeters. That is the value of x. Simply we use Pythagorean. All right, but for the angles we must use trigonometry. There are no other ways to do this. So let's start with solving for angle A. So we want angle A. So possibilities, we're going to use the values that were given to us by the question. So notice that hypotenuse is given to you, right? And the opposite side is given to you. So remember again, so this is the angle we're looking at, opposite, and we have the hypotenuse. So this is OPP, and this is your hypotenuse. All right, what ratio involves opposite and hypotenuse? That is the sine ratio. Excellent. So sine of angle A equals 7 divided by 18, and angle A, okay, equals, now this is what you need to do, sine inverse of 7 over 18. This is the part where you have to use the second function sine to get the angle, okay? And that's what you will do. So open up a scientific calculator. The first thing you got to do, make sure your calculator is in degree mode, which is right here. Then you say, okay, what was the ratio? 7 over 18. All right, 7 divided by 18. That's equals to, you get that value up here. Then you have to use second function right here, second function, and then the sine of that 0.333, which is shown, is up here for me on my calculator. The angle is 22.885 degrees, so 22.89, but because we want 1 decimal place, we just do 22.9 degrees, and that is good enough. Okay, so that's what we would do for angle A. Angle B, or sorry, for angle C, the easiest way to do angle C is the using the sum of the interior angle of a triangle equals to 180 degrees. That's the easiest way, okay? But the other way also, you can use another trigonometry and trigonometric ratio, and no problems. You can use the 18 and 7 and use the cosine, okay? But in this case, the easiest way is using the sum of the angles in a triangle equal to 180. So basically, you have 180 degrees minus, if you subtract away 22.9 degrees and subtract away the 90 degrees, whatever you will end up getting, that will give you angle C. Okay, and when you do the math on that, you get angle C equals to 67.1 degrees. Okay, so that's how you do this question. Again, I used the sine ratio. The first thing I did for the side, I used Pythagorean. You didn't have to use Pythagorean. You could use, in this case, if you didn't want to use Pythagorean, first you have to find one of the angles, then you can go ahead and solve for x. But in this case, you must use Pythagorean if you want to solve for x first. All right, and then as angle A, you're using what is given to you. Don't use the value that you just found in case you have made a mistake. So use the original values, 18 and 7, plug it in, and then use for angle C, I use the sum of the interior angle of a triangle equal to 180, which is the simplest way, or you can use trigonometry using cosine. All right, look at example B. This time we have all the sides of the triangle, okay, and that's actually a very special triangle, but we want to find the interior angles, angle A and angle C. All right, you have options now, it doesn't matter. So we're going to start with angle A. Let's just start with angle A here. So what we're going to use, let's use let's use cosine for this, just for fun, because we can use any other ratios as well. Okay, so here is, so cos of angle A. So before we do anything, we must again say what is what. So the reference to angle A, 12 is the adjacent side. We have the hypotenuse and we have the opposite. Great. Cosine is adjacent over hypotenuse, so it would be 12 divided by 13. So angle A equals to cos inverse of 12 over 13. 12 divided by 13 equals, and then trigonometry, second function, cos inverse of that, 22.62 degrees. So angle A is 22.6 degrees. Okay, and once you get that, you can use again the sum of the interior angle of a triangle equal to 180, or for fun, let's do tangent. Let's use tangent for angle C. So tangent of angle C equals, now in this case, opposite is 12 and adjacent is 5. All right, so angle C equals tangent of inverse of 12 over 5, and in this case you just go ahead and do the same thing again. All right, you punch that in a calculator, tan inverse of 12 over 5, so do the 12 over 5 first, second function tangent, you're going to get 67.4 degrees. Okay, so two different ways of doing this. I use cosine and tangent. You can use sine and tangent for A and cosine and sine for C, whatever, it doesn't matter. But as long as you're consistent, you're following the pattern and following the ratios properly. Okay, now practice time.